Today we're going to be looking at multiple representations, comparing properties of linear functions. This is lesson 2.5. So at the end of this lesson you will be able to compare linear functions from multiple representations, complete tables and graphs, and write equations to model linear situations. You're going to create functions and use them to solve problems, and this includes evaluating functions and determining solutions algebraically. Now in this first part we're going to be looking at tables as well as word problems, and we're going to be able to write a function from them. So look at this first one right here. Here's an example. You have a hot air balloon cruising at 1,000 feet, begins to ascend. Ascend means to go up. It ascends at a rate of 200 feet per minute. Now look at the word per. This is a key word, and looking at the phrase feet per minute. Now think back to topic 1, and this feet is talking about is your dependent quantity, and minute is your independent quantity. So if I see the word per, that is a key word to pay attention to this. Now when I look at this right here, now I have to write it as a function. I'm going to put f of x, and it doesn't matter what letter you put right here, as long as this letter and this letter, the x's match, or whatever letter you use right here, whether it's an x or an n or whatever other letter. And on the outside it does not matter what you put. Now I see that this right here, the 200, is my slope, and we started at 1,000. This is your y-intercept. So when I look at this right here, 200 is called your slope or the rate of change. These two terms are interchangeable right here. And the 1,000 is where we started from. This is the y-intercept. So when I look at this right here, I also could have written this in slope-intercept form. Y equals mx plus b. All I did was change out the f of x to y, and everything else stays the same, 200x plus 1,000. Now, my slope is 200, or my rate of change is 200, and my y-intercept written as an order pair 0, 1,000, or my y-intercept can also be written as 1,000 because this is where we started from. This would be your total feet over here, and then your x would be your time, the number of minutes it takes to get there. So this is what we're going to be doing on the first, on 2 and 3. Now, looking at 2 and 3, I want you to read this and look for that keyword. Remember, look for the word per, and then look for whatever's in front of per that will give you a hint as to what your slope is. And then look out in here, and where did you start? We started at 1,000 on this one. So that is our y-intercept. So read through number 2 and number 3. Number 2, you've got a bathtub that contains 10 gallons of water. The faucet is turned on and fills the tub at a rate of 5.25 gallons per minute. Number 3, a helicopter flying at 4,125 feet begins its descent. It descends at a rate of 550 feet per minute. Now I want you to write a function just like it did on number 1. You do not have to write all of this extra right here. So looking at this right here, write a function for number 2 and number 3. Pause me while you do so. Now let's look at number 2. On number 2, when we're looking at number 2, you see you got a bathtub, contains 10 gallons of water. You started with 10 gallons of water, so this is your y-intercept, and then you turn on the faucet and fill the rate. So you are increasing. So I'm going to look at 5.25 gallons. Gallons is your dependent quantity, minute is your independent quantity. Here's my per, my keyword, and also this, I'm going to put an x over here, which means this is your variable x. When I write this as a function, I have f of x equals 5.25x plus 10. So I have 5.25, and there's my x. I put it right here. We started with 10. So 5.25 is your slope or rate of change, and your y-intercept is 10 because this is where you started from. Look, and so down below here when you look at this, you see y equals mx plus b when it's written in slope-intercept form. So your slope is 5.25, and your b, your y-intercept, written as an order pair is 0, 10, or if you want to look at it as 10. Now, looking at number 3. So on number 3, you've got a helicopter, and the word descent means to go down. So it descends at a rate of 550 feet per minute. So I'm going to write it as a function. F of x equals negative 550x plus 4,125. When you're looking at all of this right here, your total feet is f of x, and your slope is rate of change. They're interchangeable, is a negative 550. And your x is talking about the number of minutes it takes to descend. And your 4,125 is your y-intercept. This is where you started from. If I were to look at this on number 3, and I were to take this right here and substitute like in 2 minutes, where was the helicopter after 2 minutes? Well, it started at 4,125, now it's at 3,025, and it took 2 minutes to go from 4,125 to 3,025. If I looked at it at 4 minutes after it started descending, it is at 1,925. If I were to write these as ordered pairs, I would have 2 and 3,025, 4 and 1,925. If I were to write, what does this ordered pair mean in context to this situation? I would say, right for this one, it took the helicopter 2 minutes to descend to 3,025 feet. After 4 minutes, the helicopter descended to 1,925. So now I've written down what this means, what this order pair means in context to this situation. You will need to be able to do that. Now, here's what I want you to do. Let's look at the next part, directions. You're going to complete the table and write the function. I've already completed the first one for you. Now, in this first part, we wrote a function. Now, when I look at number 4, you see you've got a fish tank filled with 12 gallons of water, which is drained, which means to go out. The water drains at a rate of 1.5 gallons per minute. Your gallons is your dependent, your minute is your independent, and your the variable is going to be your x. Now, I'm going to take this right here, your dependent and interdependent quantities right here. Your quantity is time, your units of measurement is minutes right here. So this goes back to topic 1. And then your gallon is volume is being measured by gallons. This is your dependent. This is what you're going to fill out on your chart right here. Now, we're going to substitute in, we're going to have to write the function right here, and I've already written it for you. F of x equals the negative 1.5x plus 12. I get that from this because your slope, your rate of change is 1.5 gallons, and it is being drained out. So this is a negative 1.5x because it is draining out. And I can put a negative right here, and so when I look at this, I'm going to put a negative right here, and let me change the font size. Now, that's a negative 1.5 gallons per minute. I'm going to take and substitute in each one of these times right here. So I can take my rabbit, I can go right here, and remember we're going to use that 1.5. So I'm going to take this, I'm going to move this over here, I'm going to turn it on, and I'm going to take a negative 1.5 parentheses, and I'm going to substitute in these numbers right here, 0, 1, and 3, one at a time. So 0 parentheses plus and it was 12. Now I'm going to come up with my answer of 12. This is where we started from. I'm going to do each one of these others. I'm going to cursor back up here, hit enter. Now I'm going to cursor back, and instead of 0 I'm going to put a 1 right here, and it's 10.5. I'm going to cursor back up here, hit enter, cursor back, and this is going to be a 3 minutes. After 3 minutes, where are we? We have 7.5 gallons now. Now they're going to give you the total right here, and you can find the total where you take the 4.5 right here and let it equal that, and come up the negative 1.5x plus 12 equals 4.5, and solve it as you would an equation. Also with the 1.5. There's another way that we're going to do this. So I'm going to take my Wabbit, and I'm going to go to another part of the calculator. So I'm going to go to y equals, and make sure this is clear. I'm going to type in the negative 1.5x, and here's the symbol for x, plus 12. I'm going to go to our table. I'm going to go to second graph, and now at 0 we have 12. At 1 is 10.5, and we skip down to 3. 3 minutes is 7.5 gallons. Now I've got to come up with 4.5. So when I look at 4.5, these are my answers over here. This is how many gallons of water you still have left in the, as you can see, in the tank. So when I look at this right here, it took 5 minutes to have 4.5 gallons. So I want to put in 5 right here. Now, how many minutes will it take for us for this to come down, for the water level to have only 1.5 gallons of water left in the tank? And it says 7, so I'm going to put 7 right here. So here's what you're going to do. Remember, you can go to y equals. You're going to take number 5 and number 6. You're going to read these. So look at number 5. You've got a submarine that's traveling at the depth of a negative 300 feet. It begins ascending at a rate of 28 feet per second. You're going to write a function right here. You're going to fill in your dependent and independent quantities, just like I did right here. And you're going to take this function, and you can put it in y equals, and substitute these numbers in one at a time, or just look at your table, just like I did right here. I can do this one of two ways. I can go to the regular part of the calculator, substitute these in just like I did right here, come up with your answers, or I can go to y equals, type in whatever function you have right here, go to second and graph, and I can cursor up and down, find my answers, whatever I need to find, and these are your totals over here, and fill this in. So look at number 6 now. You've got a free diver who's diving from the surface of the water at a rate of 15 feet per minute. Come up with your function, come up with your independent and dependent quantities, fill it in, and we'll check it back in just a few minutes. Now put me on pause while you do this. Now let's go ahead and look at your answers. On number 5, you got a submarine that's traveling at a depth of 300 feet and begins ascending, which means to go up at a rate of 28 feet per minute. So your feet is your dependent quantity, and your minute is your independent quantity. You're going to fill out this part right here. Minutes is referring to time. Feet is referring to the depth as the submarine as it goes down. Now I'm going to write this as a function. So I see that we're at a negative 300 feet. This is where we started from. Our rate of change, which is our slope, is 28 feet. This is how much the submarine is going up per minute. It is ascending at 28 feet per minute. Now I'm going to take this right here, And I'm going to take my wabbit. I'm going to come over here. I'm going to put it in. Put in 28x minus 300. And go to second and graph. And look at my table. At 0, when it will reach the surface right here, when you're at surface level, or at 0 minutes, you're at a negative 300 feet below the water. After 2 minutes, you're at a negative 244 feet because you're coming up towards the surface of the water. At 4 minutes, you're at a negative 188 feet. Now they have switched it. How many minutes will it take to get to a negative 132? So I'm going to cursor down through here, and I see it took 6 minutes to get to a negative 132 feet. So put 6 here. Same thing for a negative 76. So it took 8 minutes for you to reach a negative 76 feet. So that means you're only 76 feet from the surface. Okay, now let's look at number 6. You've got a free diver who's diving from the surface of the water at a rate of 15 feet per minute. So that means it's going down. This is your dependent and independent, your variable x, the per is your variable x. When I fill this part out, you see that minutes are referring to time, feet is referring to depth. We write our function, and you see that it's a negative 15x plus 0, or you can look at it as f of x equals to a negative 15x. I can go to my wabbit, and I can put this in. So I'm going to put this in at a negative 15x, and if you want to put plus 0 here, you can. It's not going to make any difference. I'm going to put in, go to second and graph, go to my table, second and graph. Okay, let's try this again. It just graphed it for me. Second, there we go, graph. Here's my table. Now, we have to fill this in. So when I'm looking at this right here, I'm able to go to at 0, 0. At 0 minutes, the diver had not gone anywhere. But after 1 minute, he's gone to a negative 15. 2 minutes, he's at a depth of a negative 30 feet. That means he's 30 feet below the surface. And at 3 minutes, he's a negative 45 feet. And then at 4 minutes, he's gone to a negative 60 feet. That means he's 60 feet below the surface when he dived. Now, these are completing a table using right from a function. Let's look at the next part. So on the next part, I've already completed this one for you. You're going to answer the following questions. On number 7, you've got Malik, who has a 300 gift card and uses it to pay for his karate lessons, which costs $25 per month. Now, if you started at $300 and you spend $25 a month, that's going to be a negative 25 because your rate of change, your slope is a negative 25 per month, and your variable is going to be, the per is going to be your variable x. You're going to have to look at this first one. It says to write a function that describes the dollar amount D on the card after T months. So I'm going, instead of f of x, it says to put D in the amount of after T months. So I'm going to put D of T equals, and here's my negative 25 because this is the rate of change. This is how much money we are spending per month for our karate lessons. So I have a negative 25T plus 300. Now I'm going to take that, and it says, look at part B, determine when there will be $25 remaining on the card. So I'm going to take this right here, and I'm going to solve it as I would an equation. So when I look at this right here, I'm going to set this equal to 75. And when I work this right here and solve it as an equation, you can see it took 9 months to have $75 remaining on our gift card. So it took 9 lessons. Now, the 9 is referring to your month, so you're just going to solve it just like you would an equation. Then it said explain what this means in context to this problem. So I'm going to look at this right here, and here's what it means. Malik will have $75 on his gift card after 9 months. I could even write this as an ordered pair, and when I do write this as an ordered pair, it's going to look like this. I'll have a 975, and that 975 means this, that it took 9 months for us to get to $75 left on Malik's gift card. Now, I have already worked number 7 for you, so you're going to work number 8. On number 8, suppose an elevator starts at the top of a high-rise building at a height of 372 feet above the ground level or ground floor and descends without stopping at a rate of 15 feet per second. You're going to write a function that describes the height, which is h, of the elevator after t seconds. So you're going to do it just like this. Then you're going to determine the exact time the elevator is at a height of 200 feet. And so you would put your 200 after you write your function right here, just like we did on B. Then you're going to explain what this means in context to this problem. So just like I did right here, 9 months means that we have $75 left on the gift card. So pause me while you work this. Now, let's go over number 8. So number 8, you see that I have identified my dependent and independent quantities right here. We have 372 feet. That is where we started from. And we're going down at 15 feet per second. Now, when I write this as a function, you see I have to put a negative because we're going down. This is our rate of change, our slope. We're changing the height every 15 seconds. We're going down a floor. So you're 15 feet per second. Now, it took, when you write your function h of t equals a negative 15t plus 372, you're going to take that, and it wants to, and the next question says determine the exact time the elevator is at a height of 200 feet. I'm going to set this equal to 200 right here. I'm going to solve this like you would any equation. I've got to get all of this right here. I've got to get t by itself. Now, when you write t right here, since the t and the plus look so much alike, make it look like a little curve, have a little curve on the end of it to set it off from the rest of it and make it look different, so it will not be as confusing. Now, when I go ahead and work this out, I see that t gives me 11.46 right here. So when I look at this right here, and I'm going to get out of my table, turn it back on, clear this, I'm going to take a negative 172 divided by negative 15. Time can never be negative. So if you get a negative number right here for time, something is wrong. Now, when I look at this answer right here, 11.4666, and it keeps on going, and then it ends with a 7, that means that it just ran out of space because the 6's keep on going forever and ever and ever. And what happened is the calculator went ahead and rounded it off. And I went ahead and you see I put a line over above the 6 because that means it just keeps repeating. So for the elevator to reach a height of 200 feet, it took 11.46 seconds. Now, if I were to write this as an ordered pair, it's going to look like this. I'm going to have 11.46 and 200. Now, I have to say, well, what does that mean in context to this problem situation? So when I write it, it means this. It took the elevator 11.46 seconds to get to 200 feet. Or we could say to descend to 200 feet. So whichever way you say it is perfectly fine. This is what this means in context to this situation. When you're looking at this ordered pair, you're looking at it and you have to be able to explain what does this mean. Now, look at the next one. Look at number 9. You're going to be comparing properties of linear functions using a description, table, and a function. So the first thing you're going to do, look at number 9. The table represents Dan's plumbing charges. You're going to find your slope for each one of these. So find your ordered pair. Look at your ordered pair. Find the slope for this table right here. Then turn it into slope-intercept form in order to find your B. Substitute it in. Pick any ordered pair, and then write your function. Over here, Kim's plumbing charges $25 per hour plus $30 service charge. So you're going to write your function from this, just like what we did on 1, 2, 3, 4, 5, 6. Write your function, and then go to y equals and fill this in. Now you're going to look at this and answer, when will the cost for the job be the same for both plumbers, and what will that cost be? So set them equal to each other and solve it just like you would any equation. And then you're going to write your two answers right here as an ordered pair and explain what does your answer mean in context to this problem. Pause me when you do so. Now, let's look at this. We're going to find the slope for this, and so instead of using the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which we can, I'm going to find the difference between these. I'm going to start at the bottom. I'm going to put in 175 minus 140, and I'm going to, and you see I get 35. I'm going to put in 140 minus 105, and I see I get 35. And if I were to go up here and I start at the bottom and going backwards and find the difference between each one of these, I see that my number is 35. If I start at the bottom, 5 minus 4 is 1, 4 minus 3 is 1, 3 minus 2 is 1, 2 minus 1 is 1. And then if I were to take these right here and I were to take and divide these, 35 divided by 1, I see that I would get 35. So I'm going to say 35 divided by 1 and get 1. 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 So my slope right here is 1. Now, I do not see 0 with a number 0 and another number after it. So I do not have my y-intercept right here. So I'm going to have to use my slope-intercept form to find my slope-intercept. So when I look at this right here, I see that I can use any point over here. I'm going to write down my slope-intercept form, y equals mx plus b. And I'm going to pick any set of points. I'm going to look for to see if I have a 0 or positive numbers or small numbers. So the smallest that I have is 135. This is my x and this is my y. So I'm going to put in 35 in place of the y. My slope right here is 35. My x is 1. So I have 35 equals to 35 parentheses 1 parentheses plus b. Solve it just like you would any equation. And my b is 0. And if I had to write this as an ordered pair, it's going to look like 0, 0. Now, I'm going to write this as a function. So I'm going to take my slope, which is 1, and I'm going to write this as a function. I have f of x equals 35x plus, if you want to put plus 0, it's perfectly fine. Now, my slope is 35, my y-intercept is 0. Once I have this, I'm going to come over here, and I am going to take this right here, and I'm going to take and write my function. Now I am going to take y equals, since I'm looking for a table, I'm going to put in 25x plus 30 and go to second and graph. And when I put this down, I see that I'm going to write this in. I have 0, 0, 35, 1, 55, 3, no, 280. 3 right here is 105. And then 4 is at 130. So I've just filled in my table, and from this table, since we started at 0 right here, here's my y-intercept right here, 0.35. If I have a 0 in the x place, and then I have another number over here in the y place, as long as I have a 0 in the x place, then I know that this is my y-intercept right here. And you can see it right here. So when I look at this right here, I see my slope right here is 25. My y-intercept is at 0. Here it is written as an ordered pair. Also, my y-intercept is right here, 0.35. I did not have a 0 over here in the x place, so I did not have my y-intercept given. So I had to use this right here in order to come up with my y-intercept. So if you have a chart and you have 0 in the x place, you can immediately find your y-intercept and you can finish out your function. If you do not have 0 in the x place over here, like on this side, then you will have to use this slope-intercept form right here and solve it in order to come up with your y-intercept. Now once you do that, it's saying, well, when will the cost for this plumbers be the same after how many months, and what will the cost be? So here's what you're going to have to do. You're going to have to set them equal to each other. So I did that. I took the 35x right here. I took the 35x from the first function and the 25x from the second function. So I took both of these right here, the 35x from this function, 25x plus 30 from this function, and then I set it equal to each other in order to see when will they be exactly the same. And then I solved it just like I would any equation. I got my like terms together, so I used the inverse property right here of addition. 25x becomes a negative 25x. I take it over here to this side, and then I subtract. 35x minus 25x is 10x. Bring down your 30 on this side, and now I'm going to use the inverse property right here, a multiplication, which is division. I'm going to divide both sides by 10, and I see my x is 3. So after 3 months, the cost will be the same. Now, how much will that cost be? Once you find how many months it's the same, then you're going to substitute that number in place of the function right here. So I've done this in f of x and g of x, and see after 3 months the cost is 105. So I've just answered this. When will the cost for the job be the same for both plumbers? 3, and this is 3 months. And what will the cost be? 105. Now you have to write this, or how many, not months, but hours. Now you have to write this and tell, what does this ordered pair right here, what does it mean in context to this problem situation? Well, both plumbers will charge $105 after 3 hours. So this is looking at a real world situations right here. You're comparing these tables right here and you're writing functions. Now let's go on to problem number 10. On problem number 10, you see that you're going to use the function f of x right here and compare it to this function, this chart right, or the graph right here. So look at number 10. You've got a rainstorm in Austin that lasted 3.5 hours, during which time it rained at a steady rate of 4.5 millimeters per hour. Here's your key term right here, and the word per is a key word. Now you're going to write the function and fill this in. Now looking over here, you've got the graph that shows the amount of rain that fell during the same rainstorm in Dallas. You will have to write your function. So the first thing you're going to do is come up and find your slope. So when I look at your slope right here, I see I have the numbers 4 and 20, and then I could use, here's another point. You're looking at, where does this line go through a corner? It goes right here between 2 and 10. So at this point, 2, 10. It also goes through a corner right here at 0, 0. So find your slope in the y-intercept and write your function. Now once you write your function, you're going to be able to compare these two, this table and this graph. So identify, make sure when you write this out, make sure you write m equals and b equals after each one. Identify it, write it out. Same thing for this. Identify m equals, find your slope, and b equals, find your y-intercept after you write your function. And then you're going to look down here, y-intercept of f of x and y-intercept of g of x. So you're going to use these symbols right here, less than, greater than, or equal, to compare them. This is what I would do. I would write down, once you find your y-intercept for f of x, put it right here. Once you find your y-intercept for g of x, put it right here. And then which number, is it greater than, less than, or equal, that you're going to put here when you compare the two numbers. Same thing right here. Identify your slope, write it right here for f of x. Write your slope for, or the rate of change, slope, rate of change, same thing for g of x, and put it right here. Now, is that less than, greater than, or equal when you compare the two numbers? And then substitute in 2 in place of the f of x in your function, get your answer. Substitute 2 in place of the g of x and get your answer when you substitute it in your function. And compare the numbers. Is it less than, greater than, or equal? Pause me while you do this. Let's look at these. So the first thing that you see right here, remember your slope intercept form is y equals mx plus b. So I have 4.5 millimeters, which is your dependent, your x, your per is your variable, and your hour is your independent. I'm going to write this as a function right here at f of x equals 4.5x. Now remember, f of x is the same thing as y, so I could have written it as y, but to make it a function, I have to have f of x or g of x or something like this. Remember, this x and this x has to match, or if you have an n here and an n here, it has to match. Now, I look at this right here. I'm going to go to my, I'm going to go and put this in my Wabbit, and I'm going to turn it on, go to y equals, and I'm going to put in 4.5x, go to second and graph, and I'm going to fill in my chart right here. Or if you do not have a graphing calculator, you can go and put this in the regular part of the calculator. 4.5 times 0. Put your answer down, hit enter. I'm going to cursor up here and hit enter, cursor back. Type in a 1 now directly over top. Don't hit delete, just type it directly in. And I get 4.5. I can do that all the way through, and I'm going to type in a 2 now and hit enter. And I see I get a 9. And I can do this all the way down. Cursor back, type in a 3, and I get 13.5. Cursor up here, hit enter, cursor back, and I'm going to put in 4. Now I have filled in my chart right here. So my y-intercept, by looking at a table, you can immediately tell if you have a y-intercept. The 0 has to be in the x place right here. And I have a 0 here. And so you see that my y-intercept is at 0, 0. And I've identified my slope right here, 4.5, and my y-intercept, which is 0. Now I'm going to come over here and look at this next one. So the rain shows the amount, the graph shows the amount of rain that fell during the same rainstorm in Dallas. This is g of x. Now when I look at this right here, I have to come up with my, I have to come up and find the slope. So when I look at this right here, I see that I'm going to use the slope formula right here. And I have a corner right here and a corner right here and a corner right here. I can use any two sets of ordered pairs and put it in a slope intercept form. So I use this first one right here, and I wrote out both of them. You just have to write out one. It does not matter which ordered pair that you use, you will get the same final answer. So when I put this in my slope-intercept, when I put it in the slope formula, you see my slope is 5. Now my y-intercept is at 0, 0. This is where we started from right here. And when I look at this right here, I have g of x equals 5x plus 0. I do not have to write the 0 right here, and I can just write it like this. G of x equals 5x. So your slope is 5, and your b, your y-intercept, is at 0 or 0, 0. That's the y-intercept. Now, here's what I'm going to do. I'm going to take, and since my y-intercept for this first one right here is at 0, 0, so I'm going to look and compare it. Write down the number that's directly over top of these. My y-intercept right here is at 0. My y-intercept for g of x is at 0. And 0 equals to 0. So remember, we are comparing these. Write down the number so you can actually see it. Now my rate of change, which is my slope for this first function right here, is 4.5. My slope for this graph right here is 5. So 4.5 is less than 5 right here. Now when I look at this right here, this says, well, what about if we were to substitute 2 in place of the f of x and g of x? What will it be? And so you're going to put this in, put in the 2, and evaluate it. 4.5 times 2 is 9. 5 times 2 is 10. Put the numbers here. Actually write the numbers above it. It will help tremendously. Now, so when I have this, I have 9 is less than 10. It is very easy to compare the numbers. So when you have a table or a graph like this, go ahead, once you write it in a function, identify your slope and your y-intercept. Get it to this point. Once you have it, it is much easier and faster to complete these right down here at the bottom. Now, here's what you have been doing today. Today, you've compared linear functions for multiple representations. You've completed tables, graphs, and written equations to model linear situations. You've created functions and used them to solve problems, which included evaluating functions and determining solutions algebraically, which we have done. Now, here's what I want you to do. You're going to use the function f of x, which is this one, your table, and g of x to complete the comparison table. This is just like what we just did. You have a chart, right here, a table, and you have a graph. So you're going to work it just like what we did right here on number 10. Now looking at this right here, so the first thing you need to do is find your slope. So go back to number 10. Find your slope. And then you're going to find your y-intercept. Same thing for this. And then compare them. So when I look at this right here, immediately I can tell there is a y-intercept in here. So the only thing I have to do is find my slope and then look to see if there's a 0 in the x place. If there is, then I have my y-intercept already there, and I do not have to put it in slope-intercept form and find my b that way. Now, looking at this right here, this is a little fuzzy, but you can still tell. So if I blow it up big, first off, determine, is this a positive or negative slope? And make sure that you write down the symbol if it is. Now, I'm going to write down, I can see where my line crosses the y-axis right here. What is that number? That's your y-intercept. Now, I'm going to look for a point. And so when I look, where is this crossing the 0? Where is it crossing a corner? And so I can see this crossing here, 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 here. It's crossing all the way. I can use any 2 points, and it doesn't matter the size, because every one of these, when you reduce it down, will give you the same final answer. Now, when I look at this right here, make sure you draw a triangle, and I can go from here to here. It doesn't matter where you make a triangle. Rise over run. So m equals, there's your fraction line. Determine what your rise in is, and then what your run is, and put your rise on top, run on the bottom, and then reduce it to lowest terms. If you do that, you will have your slope right here. And make sure, remember to determine if it is a positive or negative slope. Is it going downhill from left to right or uphill from left to right? Remember, read these graphs from left to right. You must be able to read these right here, left to right. Is it going downhill or going uphill from left to right? That will determine if it's a positive or negative slope. Now, when I look at this right here, I also have to determine my B. What is my y-intercept? Now, once I have that, and I have to come up and write my function for each one of these. Once I have that, then use these two functions to answer these questions. So I see f of a -3 and g of a -3. Substitute it in. Look at your slope, because remember, you're going to identify your slope and your y-intercept, your m and your b. And once you have it, you can just write the numbers here and very quickly be able to answer these. So you're going to tell if it's greater than, less than, or greater than, or equal. Pause me while you do so. Let's look at your answers. So the first thing that I had to do over here was find my slope. So once I found my slope, I see my slope right over here. I subtracted, and when I subtracted right here, I see that when I did, I came up with right here, I said 1 minus 0.05. So I'm looking at this, and then I take this, divide it by my one on the other side. And so I have to come up with my slope. And once I do that, I see that my slope is 0.5. Now, when I look at this right here, here's my y-intercept. My 0's in the y place. And so my 1 is where it's going to cross. At 0, 1 is where it's going to cross the y-axis. And when I write this as a function, it's going to be f of x equals 0.5x plus 1. You can write this with or without the 0 right here. But if you write it with the 0, it just helps you to make sure that you see the decimal right here. So that's why I did write 0.5x plus 1. It will help you, because sometimes if you have an equal and then a negative right here, a decimal right here, it's kind of hard to see that there's a negative right here. Sometimes you overlook it, so you really need to write it down. Now, do you see how I wrote this right here after I wrote the function? This will help you to determine that in order to help you to answer these. Now, look over here at this graph. Now, on the graph, I went through here and I see, well, right off, this is my y-intercept. So I do not have to put this in slope-intercept form and work it through to come up with my y-intercept, because from this graph I can immediately see this is at 0, 1. This is my y-intercept at 0, 1, which crosses at the 1 right here. And when I look at this right here, I see this is going downhill, and it is a negative slope. So when I look at this, my rise right here is a -1. My run is 1. Rise over run, which reduces down to a -1. You'll always reduce these to lowest point. Now, when I look at this right here, and I see that I have made a mistake, and I'm going to correct it. My slope right here is a 1, not a 2. So I'm going to correct my mistake, and I'm going to write it down. Now, I've corrected the mistake. I had it written correctly here, and I just miswrote it right here. So now my g of x equals to a -1x plus 1, or you can write it as g of x equals to a -x plus 1. Now, once you identify your y-intercept and your slope, which I have done right here, I'm going to take this and I'm going to substitute a -3. You see f of a -3 and g of a -3. I'm going to substitute it in, into both of these functions right here, and I see that f of x becomes, f of 3 becomes to a negative 0.5, I've written it right here, and that negative 1 times a negative 1 plus 1 gives you 4. And I've written this right here, and let me correct this one. I did not get this one corrected. So when I write this right here, you see that this is 4. And negative, anytime you have a negative number versus a positive number, the negative will always be smaller than the positive number. So negative 0.5 is less than 4. Now, since I have my slope and my y-intercept written like this, we've already written it out and identified it. So I have my f of x is 0.5 and my g of x is a negative 1. And when I look at this right here, remember, anytime you have a positive number, it is always bigger than a negative number. So 0.5 is greater than a negative 1. Now my y-intercept, my y-intercept right here for when we're looking at my y-intercept, you see that I have the y-intercept of b is 1. My y-intercept of g of x is also 1. So my f of x is 1. The y-intercept and the g of x, my y-intercept is also 1. And so when you're comparing these, you see that these are equal. Now, so go through here and make corrections and check them. And we've been able to do everything that we said we would do. Identifying your slope and your y-intercept, comparing functions with tables and graphs, and writing functions for today.